In this video, we're going to learn about the coordinate plane. So this is the number line. We all know that. So on number lines, we have those whole numbers, right? 0, 1, 2, 3, 4, and it goes up to infinity. And then we have negative numbers, right? This is negative 1, this is negative 2, negative 3, and it goes up to infinity this way. There are infinitely many whole numbers and infinitely many negative numbers, and then altogether they make integers, right? All the negative numbers, 0, and all the positive numbers, all whole numbers, make integers. Now, we know that we have fractions in between, like this is 1 over 2, this is 5 over 2, let's say, or if we say this one, for example, this is 7 over 6. I'm just making it up, of course. Now, these are just predictions of where these numbers are, actually, right? We can never know the exact place. These are just representations. However, we can predict where they are. Now, of course, we can write those fractions as decimals. So this is 0.5, or this is 2.5, and so on. So on the number line, apart from integers, we have rational numbers too. And just because there are infinitely many integers, there are infinitely many rational numbers, because you write a rational number like 5 over 2 by using two integers, right? So you can write infinitely many integers here, you can write infinitely many integers here, and you can combine these to make infinitely many rational numbers. But still, the number line itself has gaps in it. There are infinitely many integers, there are infinitely many rational numbers, but still the number line is not complete. What makes it complete is irrational numbers. Numbers like square root of 2, right? If you use your calculator to calculate square root of 2, you find something like 1.414, and it goes up to the limit of, say, the calculator screen. But actually, this bit, the decimal part, goes up to infinity without repeating. Now, pi is such a number. Pi is 3.14159 and so on, right? This bit goes up to infinity without repeating, and all these numbers are called as irrational numbers, all right? So basically, together with irrational numbers, we now have a complete number line. Now, what is next? A French philosopher, René Descartes, just joined these two number lines so that they will be perpendicular. And just because these are number lines, they have numbers on it. All the integers, rational numbers, and irrational numbers, right? So what happens is, if you write ordered pairs as in the form x, comma y, so it's x to y, and if you name this number line as x-axis, and then you name this one as y-axis, this means you're going to choose your first number in the ordered pair as x, the second one being y, right? You will have the coordinates, right? So, for example, if I was to have the point A being 1 to 3, then I would just have x value to be 1, so there will be a straight line passing through x, and then y value being 3. So wherever they intersect makes the location of A, as in 1 to 3. Whereas if you have a point B, which is 3 to 1, then your x value will be 3, so it's going to be this, right? And then y value will be 1, so basically that's going to be the point B. So you can see the difference between the location of A and B just because these ordered pairs change. So the coordinate plane, also called as Cartesian coordinates, getting the last part of René Descartes' name, right? We use these coordinate planes to locate the points in plane, or if you add a third dimension like this, which we call this as z-axis, you can just define everything in 3D space. All right? So, well, we're not going into that at this level. We just deal with coordinate plane, and this is what it is all about. We just locate points by using ordered pairs, right? And it's always x first, y last, as in alphabetical order. So this is how we use the coordinate plane. Thank you.